Today we're going to talk about implicit differentiation. So this is another form of differentiating when I have more complicated equations that have both x's and y's in them. So all functions up to this point have been written in explicit form. So for example, y equals 1 over x is in explicit form. However, that same equation could be written as x times y equals 1, and then it would need to be done implicitly. So for example, if I've got one that's written explicit or implicitly like this, I could divide both sides of this by x, get y equals 1 over x, change that to y equals x to the negative 1 power, and then I could differentiate that, and I'd use my my power rule, and it'd be negative 1 times x to the negative 2 power, which is just negative 1 over x squared. Easy. But sometimes I can't do that. Okay, sometimes I have equations that I cannot write them explicitly, and so I have to have another method. Like this one. So let's look at a few equations here. Like this one, okay? X cubed, it's already written explicitly, so I can just, since I'm differentiating with respect to x, I can just use the power rule, and I've got 3 times x squared, and I'm done. Okay, very simple. All right, but this equation, I change one thing, I change it to a y. Now that's a little bit harder, okay, because I'm differentiating with respect to x. So it's going to be 3y squared, just like it would normally be, but now I've got a function inside a function, so I've got to take the derivative of y with respect to x, and I've got to tack that on the end here. So let's look at this one. Find the derivative of, with respect to x, of x plus 3y. Well, the derivative of x is easy. That's just 1. The derivative of 3y is easy. That's just 3, but since it's y with respect to x, I got to tack on a dy dx out here. And I can't combine those. Those are not like terms. So that's as far as I can go with that. Okay, this one is the product rule. Okay, so it's going to be the derivative, it's going to be x times the derivative of y squared. So that's going to be 2y dy dx plus the derivative of x, which is just 1, times y squared. And now I can clean this up a bit, and I'll put the y squared out here in front because it doesn't have any of this added on. This would be 2xy dy dx, and I can't go any further with that, so that's the answer to that. Okay, so some guidelines for implicit differentiation. Differentiate both sides of the equation with respect to x. Collect all terms of dy dx on the left side of the equation, so I'm going to move them all to the left side. Move anything that doesn't have a dy dx to the right side. Factor out the dy dx on the left side of the equation, and then solve for dy dx. So let's look at this. I've got this equation here, y cubed plus y squared minus 5y minus x squared equals negative 4. Makes this really cool curve right here. Okay, and I want the derivative of that so that I can find slopes at different places. Okay, so here's what I'm going to do. I'm going to take the derivative of each part of this thing. So I'm going to take d dx of y cubed, and I'm going to add d dx of y squared. I'm going to subtract d dx of 5y, and I'm going to subtract d dx of x squared, and that's going to equal d dx of negative 4. Okay, so here we go. Derivative of y cubed is going to be 3y squared, but since it's a y and it's respect to x, dy dx. Plus, that's going to be 2y, again, dy dx. Minus, that's just going to, the derivative is just going to be 5, but again, there's a dy dx. This is going to be minus 2x, and there's no dy dx because I'm taking a derivative of an x, only x's. And then that's 0. Okay, so I've differentiated it. Now I'm going to move anything without a dy dx to the other side. So this is going to be 3y squared dy dx plus 2y dy dx minus 5 dy dx is going to equal 2x. Now, all of these have a dy dx in common, so I can factor that out. Leaves me with 3y squared plus 2y minus 5 equals 2x. Now I can divide both sides by this. dy dx equals 2x over 3y squared plus 2y minus 5. There's my derivative. I'm done. Okay, and if I wanted to know what the slope was at, say, the point 2, 0, I would plug 2 in for x and 0 in for y, and I would get 4 over negative 5 would be negative 4/5. There's the slope of the graph. Okay, so piece of cake at that point. I can find the slope at any point by plugging in the x and y coordinate of the point on the curve. Okay, if possible, represent y as a differentiable function of x. Okay, so here's the deal on this one. X squared plus y squared equals 0. Remember, x squared plus y squared equals r squared. That's a circle, and with a radius of r. And this radius is 0. So this is, think of it, this is just a point. Okay? A circle with a radius of 0 is a point. So that's not a differentiable function. I can't differentiate that. Okay, this one I can do. I can solve for y squared, and then I can solve for y. But remember, when you square root, you get a positive and a negative answer. So this right here is just the top half of the circle. If I want the bottom half, I'm going to slap a negative on the front of this thing, and that's just the bottom half of that circle. So I actually have to represent this with two separate equations. Okay, let's look at this next one over here. So I can take the x plus y squared equals 1, and I can change it to y squared equals 1 minus x. And then I can square root that. Okay, but again, that just gives me the top half of this curve right here. So if I want the bottom half of the curve, I have to represent it with something else. So I'm going to have to put a negative on the front of this thing. And then I've got two answers for that. Okay, find the slope of a graph implicitly. So we got a nice little ellipse here. And we're supposed to determine the slope of the tangent line to the graph of x squared plus 4y squared equals 4 at the point square root of 2, negative 1 over square root of 2. Okay, so find the slope. We have to find the derivative. Okay, And essentially, if I graph this point, square root of 2 is going to be about 1.4 negative. It's going to be right about there. We're going to find the slope of that line right there. Okay? So here we go. We're going to go ahead and differentiate both sides of this equation. And this is pretty easy. This is just 2x. This is going to be 8y dy dx. And this is going to be 0. So now I'm going to move the 2x over here because it doesn't have a dy dx. I'm going to divide both sides by 8y. And that's going to be, if I cancel the 2's out of here, that's going to be negative x over 4y. Now, I'm not done because the question asked me to find the slope at that point. So I need to take the x, substitute it in here, take the y, substitute it in there. So I'm going to get negative square root of 2 over 4 times negative 1 over the square root of 2. And this is going to be negative square root of 2 over negative 4 over the square root of 2. The negatives will cancel out, so we'll get rid of those. Remember, this is the same thing as dividing a fraction, so I invert and multiply. So this is going to be square root of 2 over 1 times square root of 2 over 4. And the square root of 2 times the square root of 2 is 2 over 4, which is 1/2. The slope of that line is 1/2. And that looks about to be what that slope is. Looks like it would rise a half and run 2, or run 1. So there you go. Not too difficult. Okay. So this is a little bit of a difficult one because it's a pretty complicated equation. Determine the slope of the graph of 3 times x squared plus y squared squared equals 100 xy at the point of 3, 1. Okay. So here we go. Let's get it to do it. So we're going to take the derivative of both sides of this equation. Okay, so here we go. This is going to be tough. I'm going to use the power rule. So 3 times 2 is 6. X squared plus y squared to the first power. But now I got to use the chain rule and take the derivative of this. So the derivative of this is pretty easy. That's going to be 2x plus the derivative of that is going to be 2y dy dx. Okay, the 100 I can just take out over here, and I've got the product rule. Okay, so that's going to be x times the derivative of y, so x times 1, plus, whoops, wait, it's not just 1, it's 1 dy dx, plus the derivative of x, which is 1 times y. Okay. Now we got a lot of cleaning up to do on this problem. So the first thing I'm going to do is I'm going to factor out this 2 here, bring it out here in front. 2 times 6 is 12. Okay, and then let's just take it baby steps here. dx. And we'll clean up this side, so this is going to be 100x dy dx plus 100y. Okay, now the problem here is I need to get this all multiplied out so that I can get the dy dx's. This dy dx is attached to the y, which is also attached to all this stuff. So I need to get it all separated. And that's a little bit of a chore. So let's see here. I'm going to take this stuff and distribute it in here. So I'm going to get 12x squared plus y squared times x plus 12x squared plus y squared times y dy dx equals 100x dy dx plus 100y. Okay, now I've got this by itself. I can get this away. I can move it to the other side. So I'm going to move all my dy dx's over here. So I'm going to have 12x. Let's put the y in the front. 12y x squared plus y squared dy dx minus 100x dy dx. That's going to equal 100y minus 12x x squared plus y squared. All right, this is looking a lot cleaner now. Okay, I can factor out my dy dx because everything over here has a dy dx. So I've got 12y x squared plus y squared minus 100x. And I just bring this stuff down over here. And now I'm just going to divide by this. So dy dx is going to equal 100y minus 12x times x squared plus y squared all over. I'm going to go ahead and put the negative 100x out here in front plus 12y x squared plus y squared. And then you could clean this up a little bit more because all of these are divisible by 4. So if I divide that by 4, I get 25y minus 3x x squared plus y squared. And then I get negative 25y plus 3y x squared plus y squared. Okay, that's about as simple as we're going to get. So now I know what the derivative is. There's the derivative, that's the slope. And I want to know the slope at a particular point, at the point 3, 1. So all I'm going to do is plug in 3, 1 into this equation. Okay, so I will get 25 times 1 minus 3 times 3 times 3 squared plus 1 squared all over negative 25 times 1 plus 3 times 3, 3 times 1 times 3 squared plus 1 squared. And now it's just calculating a number here. So this is 25 minus, this is 10, and 10 times 9 is, so that's 90, over negative 25, plus that's 10 times 3 is 30. So that's, negative 65 over negative Oh, hang on. Found an error. That's an x. So that makes this not a 1, but a 3. Can't have any evidence that that was a mistake. And then that makes this negative 75. And that makes that negative 45. And now the negatives cancel. And 5 goes in there 13 times, and 5 goes in there 9 times, and my slope is 13/9. So you got quite a bit of work there to find 13/9, but there you go. Okay, let's move along. So determine the, find dy dx implicitly for the equation sine y equals x. Then find the largest interval, negative a is less than y is less than a, on which y is a differentiable function of x. You know, if you graph this graph, make sure it goes the right way here. It goes like this. It just goes on forever. This is the point 1, this is the point negative 1. Okay, and if we're looking at a negative a, positive a, where it's continuous and differentiable, we're looking to cut this thing off right here and just look at, this should actually come out to here. We just want to look at this part of the equation. It should curve more. Okay, so here we go. So we're just looking at that green, and it turns out that this is pi over 2 right here, and this is negative pi over 2. So that's going to be the interval on which this thing is differentiable. So we just got to find what's the derivative of this thing. So we're going to go d dx of sine y equals d dx of x. Okay, this is easy, that's 1. Derivative of sine is cosine y dy dx. And then dy dx is 1 over cosine y. And our interval is negative pi over 2, pi over 2. Actually, this should be open intervals. I get in the habit of writing the closed interval all the time. Okay, moving on. Finding the second derivative. Okay, so we've got x squared plus y squared equals 25. See how it's got this little 2 here and the little 2 right there? That means find the second derivative of y with respect to x. So we'll start out, we'll find the first derivative. That's going to be 2x plus 2y dy dx equals 0. And now we're going to solve for dy dx. So 2y dy dx equals negative 2x, and then dy dx is negative 2x over 2y, which is just negative x over y. So there's my first derivative. Now we got to take the second derivative. So we're going to take the derivative of negative x over y. So we can kind of think of the negative 1. We'll just kind of factor that out. And we'll use the quotient rule. So this is going to be negative. It's going to be y times the derivative of x, which is 1, minus x times the derivative of y, which is going to be dy dx, all over y squared. Now here's where this gets a little bit interesting. What do I do with this? Well, I already know what that is. Right here, it's negative x over y. So I can take this and substitute it in there. So if I clean this up, this becomes negative y minus x times negative x over y squared. Okay, so I just substituted in negative xy into that. And then those cancel. Now, I would like a common denominator here. So here's what I'm going to do. I'm going to multiply this by y over y. So I'm going to get negative. I'm going to get y squared plus x squared all over y squared. Now remember, this is dividing two fractions. This is y squared over 1, so I can invert and multiply this. So this ends up being negative. I'm going to put the x squared first, x squared plus y squared on the top, and this ends up as a y cubed on the bottom. Now this is interesting because here's another example. I already know what this is. From up here, whoops, that's 25. So I'm going to go ahead and put 25 in there. This is negative 25 over y cubed. That's my second derivative. Okay. Let's find the tangent line to the graph x squared times x squared plus y squared equals y squared at the point square root of 2 over 2, square root of 2 over 2. Okay, so let's take our equation. We'll rewrite it down here. X squared times x squared plus y squared equals y squared. And let's find the derivative of this. Okay, so we've got let's see, do we want to? Yeah, let's just go ahead and find this. So we got a product rule here. So this is going to be that's going to be x squared times the derivative of this, which is going to be 2x plus 2y dy dx plus 2x times x squared plus y squared. And over here, this is going to be 2y dy dx. Okay, let's distribute this. So this is going to be 2x cubed plus 2x squared y dy dx. Do I need to distribute that? I really don't. So we'll just leave this like this. And while we're at it, let's just move this over here. And we'll leave 0 on that side. Now we're going to move everything that doesn't have a dy dx over to the other side. So we're going to have 2x squared y dy dx minus 2y dy dx equals negative 2x cubed minus 2x times x squared plus y squared. Now over here, I can factor out the dy dx. 2x squared y minus 2y equals, I'm not going to do anything with this stuff over here. And I'm going to divide both sides by this part right here so that I get dy dx by itself. Negative 2x cubed minus 2x times x squared plus y squared all over 2x squared y minus 2y. Okay. Actually I can, if I distribute this in here, I can simplify this a bit. So let's do that. This is going to be negative 2x cubed. This is going to be negative 2x cubed here, and minus 2xy squared. And then this will combine to be negative 4x cubed minus 2xy squared all over 2x squared y minus 2y. And in fact, I could even simplify that a little bit more because all those things have a 2 in it. So, and I can, let's factor out, let's divide this by negative 2 over negative 2. So if I do that, I'm going to get 2x cubed plus xy squared over, if I divide this by negative 2, that's going to be just y. And I divide that by negative 2, this is going to be minus x squared y. So that's nice and pretty right there. Yeah, now, okay, so the next part is we need to find out what the slope is at square root of 2 over 2 square root of 2 over 2. So I need to plug that in to this equation right here. So I'm going to get 2 times square root of 2 over 2 cubed plus square root of 2 over 2 times square root of 2 over 2 squared over square root of 2 over 2 minus square root of 2 over 2 squared times square root of 2 over 2. Now I just got to simplify all that and figure out what it is. So, here we go. Whoa. Here we go. All right, so square root of 2 cubed, that's going to be 2 square roots of 2. So this is 2 times 2 square root of 2 over 8, because 2 cubed is 8. This is actually, when if I multiply this all out, this is going to be 2 square root of 2 right here, because this is going to be 2 times square root of 2. So this is going to be plus 2 square root of 2 over, This is 4 times 2 is 8. And this is going to be square root of 2 over 2 minus, that's going to be 2 over 4. And so this is going to be 2 square root of 2. And 4 times 2 is 8. Okay, so we've got that cancels that, leaves a 4. And that cancels that, leaves a 4. Which didn't make much sense to do because, let's undo that. Because then I lose my common denominator here. So this would be 4 square root of 2 over 8 plus 2 square root of 2 over 8. That's going to be 6 square root of 2 over 8. And if I get a common denominator here, I'd multiply this by 4 over 4. So this would be 4 square root of 2 minus 2 square root of 2 would be 2 square root of 2. And that's 8 that's 8 in the denominator. And then, of course, those cancel, and I get 6 square root of 2 over 2 square root of 2, which square root of 2's cancel, and I just get 6 over 2, which is 3. Try to do that in baby steps for you because there was a lot of canceling and multiplying and stuff. Okay, so I got my slope is 3. All that for 3. That's beautiful work right there. You don't get to do fun stuff like this in English or PE or art. In fact, that is a work of art. And we're done for the day. So give these problems a try. Skip number 19, but do 1 through 25 odd, 29, 33, 35, 41, 45, and 47. And I will see you in class next time.